Hey everybody, welcome back to 5.6 angle bisectors and perpendicular bisectors. We're going to be talking about a couple of theorems today. I know we've talked about angle bisectors before, but this is going to be dealing with something slightly different. So the very first thing I want you to write down is I want you to write down the word equidistance. It says when a point is the same distance from two or more objects, the point is said to be equidistant from the objects. Okay, so we're going to be using that equidistant in our theorems. So pause this if you've not finished it. All right, so the very first two theorems I want you to write down is going to be the perpendicular bisector theorem and the converse. Write it down and I will explain in just a second. Pause now. All right, so what this states, it says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If you look at this, the question states, or this theorem states, that if you have a perpendicular line that goes through an angle, okay, that goes to a 90-degree angle, that's what a perpendicular angle is, and these two segments, AY and BY, are going to be congruent, so where it bisects that line, then the sides of these two triangles, so XA and XB, have to be also congruent or equal to each other. Okay, so because you know that that line is a perpendicular bisector, it goes down, it becomes a 90-degree angle, and it bisects AB. That means that XA and XB are going to be congruent. Okay? On the converse of that is if you look at this and you know that XA and XB are equal to each other, then you have to know that XY is going to be a perpendicular bisector, meaning YA is congruent to YB, and that XYB is going to be a 90-degree angle here. Okay, so if you know the opposite of what we talked about in the perpendicular bisector, remember that's the converse. Okay, let's try one. So please write this down. It says find the measure, or find the measure. Okay, so if we look at this, we know that MNL, that triangle, okay, we notice that there's a triangle there, but it breaks it down into two triangles here. Notice that NPL and NPM, okay? Notice that NP, that line that cuts through the overall triangle right through the middle, comes down at a 90-degree angle, meaning when it comes down and it forms a 90-degree angle, it is a perpendicular bisector, or sorry, a perpendicular line, but because we have these two segment congruent marks here, meaning that MP is congruent to PL, because we know that information, NP is a perpendicular bisector, not just a perpendicular line, but a perpendicular bisector. When it becomes a perpendicular bisector, MN is going to be equal to NL. Okay, those measures are equal. So because NL is 2.6, MN also has to be 2.6. Okay, awesome. Let's try another one. Okay, find the measure of TU using the information that you know. I want you to figure out what TU is. Find TU. Pause now. Okay, so now again, the information that we are given, we know that UW is a perpendicular line going down because of the 90-degree angle, but notice these segment marks. Because those are segment marks, it is a perpendicular bisector, okay, which now tells me that UV is going to be equal to TU, which tells me that 3x plus 9 is equal to 7x minus 17. Okay, so I'm going to solve here. I'm going to subtract 3x on both sides. So I have 4x over here, still my 9 on the left side, and minus 17. I'm going to add 17, opposite operation. So my answer is going to be 26 is equal to 4x. Divide by 4. X is going to equal 6.5. Now, I just solved for x. In your head, am I done? Question is, am I done? No. Okay, I found x, but the question asks to find tu. So because I have x, I now need to take that x and plug it into my equation of 3x plus 9. So I need to take 3 times 6.5 plus 9. 3 times 6.5, okay, is going to give you an answer of 19.5 plus 9. Your overall answer is 28.5. So what is the length of TU? It is 28.5. Don't forget to plug in that number. Okay, plug in when you find an x if that's what it's asking for. If it just says solve for x, solve for x. But if it asks you to find the angle measure, make sure you do that correctly. Okay, awesome. A couple other theorems I want you to write down. Okay, angle bisector theorem and the converse of the angle bisector theorem. Okay, so please write this down. Pause now, and then I will explain each one. Okay, so if we look at this angle bisector theorem, it says that if we have if APC is going to be congruent to BPC, okay, it's an angle bisector. Okay, but that also means if you have a line, if you have this line of AC and CB that go directly, that are perpendicular to the AP and BP, then they will be equidistant from each other, meaning they are equal. Okay, notice that it has to come down at a perpendicular angle to the side of the angles, the overall angle. Okay, the overall angle being APB has to come down and form a 90 or a perpendicular angle. Also notice that BCP, this inside angle, does not have to be 90 degrees. That's not your perpendicular angle. It's always going to be from the point down to your angle. So from C down to AP. Adrian Peterson. Sweet. All right. So looking at converse, if you know the exact opposite, you can tell me that it is an angle bisector and that these two angles are going to be congruent. So if you draw a line perpendicular to PB and a line perpendicular to AP, okay, and they are congruent, then APC and BPC have to be congruent. All right? So knowing those, and it's not just, I don't want you to just be able to look at an angle or look at an equation and say, oh, well, this is how you do it. Because remember, you have to be able to explain it. It's not just figuring out how to find an x, but also how to explain your answers. Okay, let's try one. This says find MKL, the measure of MKL. Okay, so looking at the information we know, we can notice that we have a perpendicular line that forms with KJ, okay, and that is going to be equal to a perpendicular line formed, or when it comes down to KL. Also, these lines are, again, congruent. So because of that, what information do we know? We know that this angle is congruent to this angle. In other words, we know that MKJ is congruent to MKL. How do we figure out MKL? Well, we solve. 3a plus 20 is equal to 2a plus 26. Again, the reason why they are congruent is because they are KM is a bisector of LKJ. So if you notice that KM is a bisector of LKJ, meaning they are equal to each other. Okay, I'm just going to bring this 2a over here, I like to keep my a's positive. So I have an a plus 20 is equal to 26. Subtract 20. A is equal to 6. Okay, am I done? No, I'm not done. I'm not done yet. Because remember, what is the question asking me? It's asking me find MKL, don't find A. So what is MKL? MKL is 2A plus 26. Plug in your A, your 6 for your A. 2 times 6 plus 26. You have 12 plus 26. Your answer, 38 degrees. Don't forget your degree symbol. You're finding the measure of an angle. Awesome. Questions? Concerns? Otherwise? Sweet. All right, we are on our last slide, and I want you to give this one a shot. It's going to be asking for explain. Explain something. Be able to explain it in your notes and write your explanation down. Try this problem. It says given that line L is perpendicular is the perpendicular bisector of DE, prove that triangle GED is isosceles. Remember, you have to remember what an isosceles triangle, a perpendicular bisector, and how you can prove that. Give this one a shot. A great way to do this is just to put it into a quick 2-column proof. Okay, what information do we know? What information do we want to get? Okay, so I'm going to put this into a 2-column proof here. Right like that. And my first information is, well, L is the perpendicular bisector of DE. So that's going to be my statement. That's the first thing I know. Notice that I use the perpendicular symbol right here in my statement. I can do that because I'm talking about a perpendicular bisector. Okay, so that was given. All right, second one. What do I know based on perpendicular bisectors? What do you know? Well, first thing you know, this has to be 90 degrees. But what do you know about DF and FE? You know they're congruent. Okay, so DF is going to be congruent to FE. Why? If you remember, a perpendicular bisector tells you that this is that they were congruent to each other. Okay, so technically that was given as a perpendicular bisector. Okay, that piece of information was also given. Okay, so because we know that that is a perpendicular bisector, okay, number 3, we can say that DG is going to be congruent to GE, and that's something we just learned based on our perpendicular bisector theorem. So that states right here. Well, so now we have over those two sides to DEG, or GED. So my fourth one is just going to be, I've already proved it, now I'm just going to say it. Triangle GED is isosceles. How do you know that it is isosceles? Well, that's the definition of isosceles triangles. Okay, so that's what I like to use 2-column proofs in explanations because it gives you definitely a good layout, good organization tool. Not to mention you're going to be writing them. Okay, so it gives you a little extra practice, and it allows you to explain your answers just a little bit more. All right, we are done for the day. If you have any questions, once again, always ask me tomorrow, and I will give you your homework. Have a great day.